Hello, my dear students. Welcome you all to Sri Jain Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, I am going to start with conformational isomerism. Conformational isomerism, which is shown by alkanes. It is a type of stereoisomerism. It is a type of stereoisomerism. In this type of isomerism, the different arrangement of atoms in space, in three-dimensionally, that results from the free rotation of group means carbon carbon double bond of group along or about carbon carbon single bond, sorry, not double bond, single bond, carbon carbon single bond. X's are called conformers. In the carbon-carbon single bond provides free rotation, a rotation of 360 degree, and the groups which are attached to carbon-carbon single bond because of the rotation of carbon-carbon single bond, that is movement of this or the rotation around its own axis, there are different structural formations which are in which you can see these formations are known as what conformers, okay, and the phenomenon is known as what conformational isomerism. The basic structure of molecule of the molecule the basic structure of the molecule with various bond lengths and bond angle remains the same. When there is no change in the bond length, there is no change in the bond angle. Okay. There are infinite number of conformers of any molecule number of conformers of any molecule two out of them are defined as staggered and eclipsed. Staggered, which is the most stable form, and eclipsed, which is the least stable form. Okay. Conformational stereoisomerism can also be defined as different non-identical arrangement of atoms or group in a molecule that result by the rotation about a single bond, about a and that can easily be reconverted at room temperature. Okay, it is known as what? Conformational isomerism, and the different forms which are which you can see. Okay, they are known as what? Conformers. Okay, now moving to the next. What are the condition of conformation? There should be three sigma bond present in a molecule. Projection of tetrahedral carbon atom. Carbon atom. There are two types of projections. One is Newman. So according to Newman projection, in this method, the molecule is observed along the central carbon-carbon rotational axis along the central carbon-carbon bond. A circle is drawn and the center of the circle represents the front carbon. Represents the front carbon. The bonds of the front carbon are drawn from the center from the center of the circle, while the bonds at the back carbon are drawn from the periphery. From the periphery. Okay, like this is the circle. Okay, a circle is drawn in the center of the carbon represents the front carbon. So this is the front carbon. Okay, the bonds from the front carbon like this, and bonds from the periphery they are back carbon. back carbon, front carbon. Okay. Now, sawhorse projection. After Newman, we have sawhorse projection. The central carbon-carbon bond of the molecule is represented by a straight line. By a straight line written in bond of the molecule is represented by the straight line written in slightly tilted manner. Slightly tilted manner. The central carbon-carbon single bond, carbon-carbon bond of the molecule is represented by a straight line written in bond of the molecule. Okay, so bond of the molecule, they are represented by a straight line written in slightly tilted manner, and the molecule is observed from the right side. Okay, like see, straight line, straight line. Okay, dihedral angle. It is the angle between valencies of two adjacent atoms. Now we are going to talk about conformation in ethane. That is CH3 single bond CH3. Carbon carbon tilted line, straight line, straight line, straight line, straight line, straight line, straight line. Okay, this is sawhorse. If there is 60-degree turn, this is eclipsed form. Okay, now we rotate the molecule at an angle of 60 degrees. Then what will be the change? Then we will get a staggered form. Tilted line, tilted line, straight line, straight line, straight line. straight line, straight line, straight line. This is staggered. Okay. For Newman's projection, front carbon, front carbon hydrogen bond, back carbon hydrogen bond, 60-degree rotation. This is eclipsed. Front carbons, now back carbon. Okay. So there are two forms, eclipsed and staggered, for Sawhorse and as well as for Newmans. Eclipsed form, when hydrogen atoms of one carbon are directly behind the other. Staggered form. The hydrogen of two atoms are maximum distance. Skew form or gouge. Intermediate, different forms which exist between 0 to between eclipsed and staggered. Okay. Stability. The eclipsed form is less stable. Staggered form is more stable due to van der Waals repulsion and torsional strain. And torsional strain. The most unstable is eclipsed, then skew or gouge, which is the intermediate form, and then staggered. Torsional strain. Repulsion between atom or group of atoms known as van der Waals repulsion. This bond pair repulsion in eclipsed form is known as torsional strain. Is known as torsional strain. Understood? Now we are going to plot a potential energy curve Between eclipsed and staggered, for ethane, this is 3 kilocalories. Potential energy versus rotation. -60 degree, 120 degree, 180 degrees. Staggered, eclipsed, again staggered. Okay, so the eclipsed form minus the staggered form comes to be 3 kilocalories per mole. Okay, this is the torsional strain. 12.5 kilojoules per mole. For confirmation propane, this is 13.5 kilojoules, 13.8 rather. 60 degree, 120 degrees, 180 degrees. Okay. In confirmation propane, we get eclipsed, staggered, eclipsed. In confirmation butane, we get one fully eclipsed, then partially staggered or gouge, partially eclipsed, then fully staggered or anti-form, then partially eclipsed, and partially staggered again. Like when you plot the graph, this is 8 kilocalories, This is 3.4 kilocalories. Okay. Then diform fully staggered is more stable than gouge, which is more stable than partially eclipsed and then fully eclipsed. Okay, this is the stability. There are some important examples which we have to discuss, like ethylene glycol. Front carbon, back carbon. Staggered form. Now you can see this oxygen comes up with hydrogen bonding with this, okay, hydrogen. So gouge form is more stable in ethylene glycol, most stable due to hydrogen bonding. Where Z can be OH, NH2, F, CHO, COOH, OCH3. Gouge in all cases due to hydrogen bonding. In all these substituent atoms, gouge is more stable because of hydrogen bonding. Gouge effect. In a lone pair containing compound, bulkier group should be placed in gouge. The group which is more bulkier is 60 degrees. From lone pair, from lone pair, as lone pair has minimum steric repulsion. That's why it is given a position of 60 degree. Okay, like for example, okay, this form is more stable than the previous one. Okay, as it is already mentioned that the lone pair has minimum steric repulsion. So a lone pair containing compound that is bulkier group should always be placed in the gouge that is 60 degree form. Okay, which is having the lone pair. Because lone pair offers the minimum steric repulsions. Okay. Another example I will give you of isopropyl alcohol, lone pair H. This form is more stable than this form. Okay. Now, the next is conformation in cycloalkanes, which I will be starting in next turn. Till then, bye bye, take care, stay safe, stay healthy.